Yes, study of characteristics of PN junction. I told you what is PN junction in detail. The symbol of PN junction, is this is the symbol of PN junction. So now there are two circuits for this, reversely biased and forwardly biased. So how to vary the voltage and current? Suppose here it is PN junction diode. Here we connect it in reverse bias. It is a rheostat here. The symbol of rheostat, and now I bias reversely. Negative, positive, negative, positive. Here I connect microammeter, plus minus, and connect here a voltmeter, battery, microammeter, voltmeter, plus minus, RH rheostat as potential divider. If I move this, actually you have seen rheostat in lab, we can move this. If I take this side, potential difference decreases. If take this way, increases. This is PN junction here. This is a circuit diagram used to study reverse bias characteristics. Now forward bias, reversely biased. Now forward bias, PN junction, rheostat again as potential divider. Now positive terminal of this side. We need only battery of 6 volt, not more than that. Sorry. Here is milliammeter, plus minus, and voltmeter here, plus minus. This is a simple diagram which we use to, I write positive negative also, you will get confused. These are two circuit diagrams. Here we study reverse bias characteristic. It is forward bias characteristic. In figure you can understand again, it is PN junction. And here I connect battery, whose voltage can be varied, reversely biased. Voltage can be varied like this. Ammeter, micrometer are connected here to show. Forward bias mein it will be positive. I told you when diode is reversely biased. When diode is reversely biased, the P region connected to negative terminal of battery and N terminal and N region connected to positive terminal. This rheostat here is to change the voltage only. Rheostat has two functions, current divider and voltage divider. So it is used as voltage divider. So initially when voltage, reverse bias voltage is low, there will be a weak current which will be due to minority charge carrier. I told you here, holes are minority here, electrons are in majority. Majority electrons are collected by battery, and here holes are collected by battery. But minority charge carrier holes are there, electrons are there. They will jump, the difference width will increase, but a weak current may flow. And when we start increasing the reverse bias voltage at certain high voltage, the material of PN junction in the depletion layer get ionized. Why? Because there is junction field as well as applied field in the same direction. The two get added, and when it exceeds a critical value, the material inside PN junction is ionized and large current flows. That is called electrical breakdown take place. When the material of depletion layer region in diode get ionized, that is called electrical breakdown and a large current flows. That current remain does not depend on voltage then. If you keep on changing voltage, current remain large. So below breakdown voltage, very weak current flows. I can show here reverse bias voltage like this. Here reverse bias current in microampere. Reverse bias current. I mean, voltage like -2, -4, -6, -8. Weak current flows. And at certain voltage, current becomes sufficient large. It becomes independent of voltage. Current remains same. Voltage may change, but current does not change. This current, this value of current at this voltage, it may be 10, 20 microampere. Now it is microampere. So if we try to find resistance under breakdown voltage, if the diode is used below breakdown voltage, it allow very small current, which is negligibly small, and we say no current flows, and it offers infinite resistance. This is one characteristic in reverse bias. This PN junction offer large resistance. Now, and current increases, but voltage does not change. This property of diode is used in electric circuits as voltage stabilizer. You see in your houses, stabilizers are there connected in with the AC and some other like computer, because they can't tolerate the fluctuation. So when beyond a certain voltage, breakdown voltage changes, so voltage may increase but current does not change. Sorry, current increases but voltage does not change. Voltage remains constant. So that is one use of the PN junction diode in voltage regulators, electronic regulators. Initially we were using manual regulator. In home we use, I have told you, while teaching AC. Now in forward bias, this circuit is forwardly biased. So here current will flow this way. Now initially I have told you when this is a diode here and depletion layer PN junction, when voltage remain below potential barrier, यहाँ एक potential barrier मिलता था 0.5 volt, तो no current flows. Okay, depletion layer thickness decreases. But as soon as the voltage becomes above potential barrier, current increases rapidly. I can plot the graph here between anode potential and node voltage and forwardly forwardly biased current. It will be in milliampere, 10, 20, 30, 40 like this. 1 volt, it is in volt only. 2 volt, 3 volt, 4 volt. So till the voltage here is less than potential barrier here, no current flows. Remain current, but as soon as it becomes above knee point, it starts increasing. Here the slope of this graph give dynamic resistance R equal to delta V upon delta I. So reciprocal of the slope is equal to resistance. But above knee point here, we call knee point, above knee point, this point is knee point. Above knee point, diode offers no resistance almost. Diode offers no resistance and act as ideal conductor. This fact is used. Diode act as ideal conductor. It offers no resistance above knee point. This fact is used in using PN junction diode as electronic switch. Those electronic switches are called gates, electronic gates. Actually, in computer and communication, we use digital signal. Two types of signal are there for sake of your knowledge. Analog signal, voltage time graph or current time graph, like this, VT graph. This is analog signal. I have told many times that our antenna receives electromagnetic wave because of electric field of electromagnetic wave. Alternating current is produced in the antenna which is carried to the devices like TV or radio. If that voltage very regularly periodic time, that is called analog signal. In that what happens, small values of voltage may not be sensed. These small voltage by the sensor may not be sensed. So signal become weak. To avoid this quality of signal, we use digital signal. Voltage remain either 0 or maximum. 0 or maximum. This is our digital signal. Digital signal. So this diode is used as now to obtain digital signal also, because above knee point it offers no resistance. Actually, that has been those circuits have been deleted from the syllabus of class 12. Very unfortunate. Millimeter. So you please. तो मेन थिंग क्या है? What are the two characteristics? Main characteristics are number 1, in reverse bias, in reversely biased circuit, PN junction offers infinite resistance and hence current is 0. If reverse bias voltage reverse biased voltage is equal to breakdown voltage, then current is significantly large and does not change with the change of voltage, does not change with change of voltage. Reverse bias current, if the applied voltage is equal to breakdown voltage, becomes independent. This fact is used. This fact is used in using diodes as electronic voltage regulator. Number three, when diode, I should say PN junction, is forwardly biased, then no current flows. If no current flows through the diode, through the PN junction, through PN junction, if voltage is less than potential barrier, no current flows through the PN junction circuit if applied voltage less than potential barrier. Number 4, when voltage applied in forward bias is above potential barrier, current increases rapidly, above knee point. I have shown in the graph knee point. Above knee point, sorry, diode, the PN junction acts as an ideal conductor and hence it offers no resistance. These are the facts which help us in understanding the working of PN junction diode. There are many other factors also on which we can change the characteristics. I told you photoconductivity, etc. We will be using dopant concentration, other factor, and material of diode. But we are limited here only to elemental semiconductor like silicon, germanium. So in the coming topic, I will tell you the use of diode as rectifier. Thank you.